Okay, so next lesson is averages and standard deviation. Before I talk about that, I want to remind you of the overarching problem that we're working on. So remember, we want to understand how Einstein proved the existence of atoms. And we want to be able to do that ourselves. And so we want to think, how can you extract information about things you don't see from things that you do see? And now actually when I'm looking at the camera, I can see like these little things moving around. So I see like these little particles, like whenever there's like sunlight going in, you see them moving around like randomly. So that's the kind of phenomena that we're going to use to extract information about the size of atoms. Okay? So how would that work? Remember that we have like some microscopic particle that you can see in the microscope, and there's like atoms which are like much smaller than this particle. So this is like on the micrometers, this is like less than nanometers, right? So this is like 10 to the minus 10, this 10 to the minus 6, something like that. So you have a lot of atoms here that you can't see, and these atoms are bumping into this particle and imparting their momentum or a force to it. So to understand this process, we need to understand something about mechanics and force transmission, which we will do in the next module. But we also need to understand something about statistical mechanics, which is you have these particles, we don't know exactly in what state they are, we don't know exactly how they're moving, but we know like maybe the temperature, right? We know something about temperature, which is something we're going to talk about in a different module. But we have an intuition of what it is. Temperature is just related to the average energy or kinetic energy of all these gas particles, right? So we need to understand whenever you want to talk about energy or temperature, you're actually talking about averages, okay? And whenever you're talking about thermal fluctuation or these things where these things where these particles hit this bigger particle but at random, what controls the force, the force that this is going to undergo, like the trajectory, is not just the average but also the standard deviation. Okay, so I'm going to talk about both of these now, and by the end of this video we're going to do a simple problem that you will work out also yourself of how we can use averages and standard deviation to understand this kind of process. Okay, so first of all, remember when we're talking about probability, we're talking about something happening with a set of possible outcomes, right? So a measurement, and a measurement produces your basic outcomes. And we said in the previous video, so let me say like, so here's outcome 1, outcome 2, and so on. In this example, the outcome is how many particles are hitting this bigger particle, or how many atoms are hitting this particle from the right and how many are hitting it from the left, right? So in this case, these outcomes would be like at time, like let's say t equals 0, how many particles hit it from here, how many hit it from there, you put that over there. Or it could be like the total force from all the particles. So it would be these guys pushing it that way, these guys pushing it the other way, and like the contribution of the force from here minus the contribution of the force from here would be your total force, and that would be your outcome over there, right? So you have a bunch of outcomes. Each outcome has a probability. So you have for this set, you have like the probabilities are like P1, P2, up to Pn. Each one of these is a number that is greater than 0, and if you add them all up, you have to get 1, because that is a reflection of the fact that this, like, whenever you do an outcome, you have to get at least one of those, right? So you're guaranteed 1 to get one of those. That's why the sum is 1. And if you want to understand that more, you can watch the previous video or go back to the previous lesson. So what is an average? An average, let's use a different color. So an average, let's write it like that, of this process. So you give me the outcomes, you give me the probabilities, I can compute the average. What is the average value? And I'm going to tell you what it means intuitively in a second, but all it means is I'm going to sum. So the average would be P1 times the value O1 plus P2 times the value O2 and up to Pn times the value On. Notice that in order to compute an average is a number. So I had to convert the outcome. The outcome didn't have to be a number. It could have been like, you know, like we said last time. It could be rain, shine, whatever, possibility, whatever thing you get. So these could have been words and not numbers. But in order to compute an average, what people do, and what you have to do, you want to get like a numerical quantitative estimate of whatever is happening. So you can say, okay, if it's rain, I'm going to give it the number 1. If it's snow, I'm going to give it the number 2. If it's shiny, if it's just sunny, I'm going to say it's 0. So then you convert that like to 1, 2, 3, or whatever number you have. And usually that's like, you can write it as another set. And so these are values, x1, comma x2, comma x3. So these would have to be numbers. Okay, and then I can change this over here. Now we have numbers here. Right? And that's how you get this average, which is a number. So what does an average mean? What does it mean intuitively? Well, let's look at it from a pictorial way. So let's say, here's my outcomes. And let me just give them numbers. Like this, let's say it's like -1, -2. You could give it minus or plus. -1, 0, 1, 2, 3, for example. What is the average? Let's say each one of these has equal probability, right? So this is your first challenge. You have these possibilities. Each one of them has the same probability. What is the average going to be? So pause the video and try to work that out. It should be easy at this point for you. If it's not, of course, you can always ask questions. So try that out and continue after you have an answer. Alright, so assuming that you tried this out, what we said last time, if each one of these has the same probability, well, you have to count. There's 6 of them. That means each one has a probability of 1 over 6, 1 over 6, 1 over 6, 1 over 6. Right? And here's the definition of average. So you do 1 over 6 times -2 plus 1 over 6. So I'm just gonna put the 6 in the denominator for all of them, because it's going to be 1 over 6 for each one. So I just have to do -2, -1, plus 0, plus 1, plus 2, plus 3, right? So that's what the average is. And then you have -2, -1, that's -3, plus 1, that's -2, plus 2, that's 0, and then you get 3 over 6, which is equal to 1/2. Right? So if I look here, and I actually try to go to the center of this line, I'm starting at -2 and ending at 3. So you notice that the center of this distribution is here. There's a different color. So the center is here, which is between 0 and 1, because there's 3 on this side, 3 on this side. So the center is 1/2, and that's the average. And that's actually what the average is. If you remember, like from the normal distribution looks like this. This is 0, and this is the probability. So in the normal distribution, this could be like the length of somebody, the length of the person, and the probability that a person has that length. So you want to look at the distribution of all people, and you say, how many people have this length that would be given by this height, right? Again, the average would turn out to be the center of this distribution. But another thing that you can have, the same distribution, you can have a different distribution, but with the same average. So that would be something like the same center here, but it's much wider, like that. Right? This is narrow here, this is wide. Has the same average. What can distinguish these two? What can actually distinguish them is what is called the standard deviation. Okay? So we did one example on the average, and you intuitively know that the average is the center of the distribution. Of course, like I can have an average distribution like this, where this is like the probability. The average will be here. Again, this standard deviation will give you the width. If I had something like, like this, but this one is bigger, then the average isn't going to be in the middle, it's going to be closer to this one. So that's just intuition for what the average is. Okay, so now we're going to look at the standard deviation. You can call it this. This is, once you've computed the average, then I go to every outcome. After giving every outcome like its corresponding number that you can give it, you have to define, you can choose what that number is for whatever situation you're interested in. In our situation that we're interested in, this is going to be the force. Okay, so we have the standard deviation, we have this number. So the way that you define it is, you say the first number, x1, minus the average x, what we call average AVG. Actually, another way to call the average, another way to represent it instead of saying AVG would be like x and a bar over it. So this is x bar, this represents the average value that we defined before. And then you square that. And then plus, of course you have to times by the probability of the first one. Each quantity is, we say, weighted by that probability. Then you have x2 minus the average squared times that probability. And then you do the same thing for up to xn. You add all of them. For each outcome you add one contribution. So this is up to xn minus x bar squared times the probability of the n1, the last one. Okay, so this is the standard deviation. Of course you have to take a square root. This is how it's defined. If you didn't take the square root, it would be called the variance. Okay, so this is what we have. Let me tell you why, where did this definition comes from, and why does it give you width, right? So let's look at it. Let's look at an example like that. I'm gonna plot. Again, I have like some example, like 1, 2, 3. Right, like 1, 0. Let's say -1 and 1. And each one has the same probability. So if I was plotting if this axis was the probability of x and this was x, then it would just be a constant. Just by definition at this point. This has probability 1/3, 1/3, 1/3, and if you actually work it out, you can see that the center is at 0, so the average is going to be at 0. And then what do you get for these numbers? So I have this one with probability 1/3. So you're going to get 1/3 times -1 minus 1 is this value, minus 0 is the average, and then squared. So this gives you +1. The 0 is going to be just 0 minus 0, and will not give you anything. It's just going to be 0. The 1 is going to be 1/3, and 1 minus 0, and then squared. Notice that the reason why we have this squared, and then you take the square root here. Notice that the reason why we have this squared is that we don't care if you're going that way or you're going that way, contributes the same to the width. And remember, like -1 squared would just give you 1. So that's why we define the squared, because we don't care about going. We want the same contribution to be, if you're this much away from the mean, you want the contribution to be the same as the contribution if you're the same amount in the other direction. So this standard deviation is just the width of a distribution, the width of this thing. It gives you a measure of the width, and it doesn't matter if the width is that way or that way. We want to get the same number. So that's what we get. And if these values, first let me write just what the answer is. So this is 1/3 plus 1/3, because that's 1 and that's 1. So you have square root of 2/3. That's the answer. Now if I, instead of had -1 and -1, I had like 2 and 2, then over here you get 2 squared, which is 4, and over here you get another 4, and the answer would be square root of 8 over 3. So it's going up, and if I divide this by this one is actually 2 times bigger. This is 2 times bigger than this, right? And you notice that, of course, it's 2 times bigger, because if you look at the distribution, now it goes from -2 to -2 to +2. So that's, the width over here is 4. The width over here is 2. So the width is twice as much. That's why the standard deviation is 2 times as much. So that's why that you see from this example, the standard deviation measures the width of that distribution. Okay, if that makes sense, good. If it didn't make sense, please ask questions below. In the next video, we're going to talk about how averages and standard deviation come in this problem. We're going to do a very simple toy problem. You're going to do a very simple toy problem where you're going to calculate the average force on this particle given from the atoms that are hitting it. Okay, so we're going to do a very simple toy problem that will make us start to get intuition for how Einstein proved that atoms existed. Okay, so thank you for watching, and see you in a bit.